Okay, good morning. So this is chemistry, and we're going to be working with electrochemical reactions. This is a 2022 past paper. I think, if I'm not mistaken, I think it's the Gauteng past paper. Let's just quickly check. Nope, it's the KwaZulu-Natal province 2022 September past paper. It's downloadable. If you want me to send it to you, I can do that. Okay. And we'll be dealing with electrochemical reactions, and we're going to be starting off with question 8. Okay. So it says that the equation below represents a reaction that takes place under standard conditions in an electrochemical cell. Okay. So the equation below represents a reaction that takes place under standard conditions in an electrochemical cell. It's telling us X is an unknown metal. The initial EMF of the cell is this, which is 0.35. Oh, let me do this. Move it all the way to the end. Okay. It says the initial EMF of the cell is 0.03 volts, positive 0.03 volts, and the cell uses platinum electrodes. Okay. Question 8.1. Write down the type of electrochemical cell in which the above reaction takes place. Write down the type of electrochemical cell in which the above reaction takes place. It's either volcanic or galvanic cell. Okay, so it's volcanic or your galvanic cell. Okay, it says 8.2, state two standard conditions for the above cell. So you're looking for standard conditions. Temperature, okay, so temp, oh, my bad. Just looking for this. Okay, so state two conditions for the standard conditions. So the temperature will be at 25 degrees Celsius, okay? And the concentration of your electrolytes, concentration of electrolytes will then be 1 mole per cubic decimeters. Okay, so those are two standard conditions for the above cell. Okay. 8.3 then states, is the above reaction spontaneous or non-spontaneous? Then give a reason for your answer. So is it spontaneous? Is it no spontaneous? Is it spontaneous or is it not spontaneous? Give a reason for your answer. In this reaction above here, the reaction is definitely spontaneous. And the reason for that is that no external energy is required, as you can see. So it's spontaneous, and then the answer is that no external. I don't know if I should maybe type these out. Maybe it'll work out quite better. So it's spontaneous. Spontaneous, external, no external energy is required. There we go. Much better. Okay, cool. 8.4. Write down the cell notation for the above cell. Okay, so now we're going to write down the cell notation. Okay, so the cell notation, I need a bit of space. So this is what we're doing over here. Okay, so we have PT solid or our Fe2 plus. Okay, which is 1 mole per cubic decimeter. Okay, we have Fe3 plus. Okay, which is also 1 mole per cubic decimeter. Then you have the other side, X plus, which is also 1 mole per cubic decimeter. Then you have X, which is a solid. Okay. So then this would be our cell notation for the above mentioned cell. So just like a quick revision, what is cell notation? Okay. Cell notations are shorthand descriptions of volcanic or galvanic cells, spontaneous cells. Their reactions, conditions, pressure, temperature, and concentration, and the cathode, and the electrode components are described in this unique shorthand. Okay, so that is what a cell notation is, which is what I've just written down right here. Okay, then says 8.4.2 says write down the half reaction that takes place at the cathode in the above electrochemical cell. Okay, so just a quick revision again. What is an anoid? An anoid is a positively charged electrode in which the electrons leave the electric device. Okay, and then right now we're dealing with cathode. Cathode is then an electric device where electricity is given off or flows out, and the cathode is a negative side, and this is usually where your oxidizing electrodes. No. This is usually where your reduction reactions take place. Okay, so it's electrodes where your reduction reactions take place. So if you know that, okay, my cathode is on my negative side, it's where what's this thing? It's where my current flows out, right? It's given out, and it's where my reduction reaction takes place. And what is reduction reaction? Reduction. It involves the transfer of electrons from one species to another. No, that's oxidizing. So it's when you're okay. Wait, just give me a moment. I'm just trying to understand. I'm confusing myself. I'm really sorry. Okay. So half reactions take place at the cathode. The cathode is on the negative side, and it's where your reduction reactions take place. So if you know where your reduction reactions take place, you're able to write your half reaction. Okay. So in this case, we have here. So reduction reactions is when you gain an electron, and then this becomes an oxidizing agent. Okay. So you have the equation would then be your half reaction, not your equation. Your half reaction would be x e x plus, my bad, x plus gains an electron, and then it becomes x solid. Okay, if you ignore if you omit the ion, okay, this, If it's omitted, then you just root x a q plus e. You're gonna get 1 out of 2. So you're gonna get half the marks. Okay, so included. Okay. If your error is facing the opposite way, this is incorrect, you get 0, even though everything is correct. Okay. So these are things that you need to kind of keep in mind. Okay. And you don't have this, you don't use the sign. Okay. The electrons aren't moving in between. They literally, yeah, the electrons aren't moving in between these two. Okay. 8.5 says identify metal X with the aid of calculation. Okay, so we're going to calculate, we're trying to identify metal X, and then we're going to kind of do that with the aid of calculations. So I'm going to do it underneath here. Okay, so I know that my electrodes and the cell are equals to the reduction right minus the oxidation. Okay, and it's given here, they're telling us that the initial EMF of the cell is positive 0.3 F. So the EMF in the cell is 0.03 K. This is the reduction equation. We don't know the metal, so then this then becomes the reduction unknown minus 0.77. We know our Fe. Okay, that one is known. Iron is known. Okay, so we know our iron, so then that is 0.77. So that means then the reduction is equals to 0.80 volts. Okay, and then we can look that up. So now that we know it's 0.08, 0, we know that X is Ag. X is Ag, which is our silver. X is the element is silver. Ooh, it looks like a weird sign. Okay, we're going to move on to question 9. Okay, so it says the simplified diagram below shows an electrolyte cell used to electroplate iron spoon with copper. Okay, to electroplate, and the term electroplate means the process of using electrode position to coat an object in a layer of metal. So they're trying to coat these iron spoons with copper. Okay. Define the term electrolyte. Definition. So electrolyte is a substance that forms free ions when melted or dissolved. I think I can quickly type it. Okay. So it's a substance, or maybe I can, nope, there it is. Okay. So it's a substance that forms free ions when melted or dissolved. That's what an electrolyte is. Okay, awesome. Kind of disappearing. I don't know. Oh, it doesn't disappear. Okay, so that's the definition. Says, I'm assuming it's 9.2. It's kind of cutting off. Okay. 9.2 says identify the anode in the cell. Choose between electrode P and the ion spoon. So what is our anode? Again, so an anode is a positively charged electrode which the electrons leave an from by which the electrons leave an electric device. Okay, it's negatively charged electrode, positively charged electrode by which electrons leave an electric charge. Okay, so when they say choose between electrode B and the ion spoon, which between the two is an anode? Which one? The answer is then electrode B. So that would be the answer. Electrode P, sorry. Okay, 1.3. Write down the equation of the half reactions that results in the plating of the spoon. So write down the half reactions. The half reaction is then C2 plus. Okay. It's different that there's no equation at all here. Okay. Other question we were given an equation, but here we know that this is what's going to happen. Okay, 2 marks. Again, if you omit an ion, you're just going to get 1/2. So make sure that you include this 2 plus. Okay, 9.4, the polarity of the DC source is reversed. Okay, so the polarity of the DC source is reversed. So you have your DC power source. Now they're saying the polarity of it is reversed. How will the mass of the electrode P be affected? The polarity of the DC source is reversed. How will the mass of the electrode P be affected? Choose from increased, decrease, or remain the same. Give a reason for the answer. Okay, so the answer is then increased. And then what's the reason? Why would it increase? Okay, so it's increased. Okay, it will increases. And the reason for this is that reduction takes place at electrode P. At electrode. Okay, so increases, reduction takes place at electrode P. 9.5. The copper used in this electro electrolytic cell is not pure. I've been saying electrolyte. Oh, it is electrolyte. Okay. So the copper used in this electrolytic cell is not pure. It contains small percentages of zinc. It's not purely copper only. There's a small percentage of zinc. They say write down the name or formula of two cautions present in the electrolyte. Write down the name or formula of two cations present present in the electrolyte. Okay, so we have zinc ions. That's what we have. And copper ions. Which is Cu2 plus. It's not just this only, we also have zinc ions. Okay. It is observed that the zinc ions are not coated. Oh, it is observed that the ion spoons are not coated with zinc. Okay, we know that it's not purely copper, right? It's not the copper used is not pure. It has both zinc ions and copper ions, but then it is observed that the ion spoons are not coated with zinc. Explain this observations in terms of relating oxidizing strengths of the substance. Okay, so we know that copper ions is a stronger, we know that it's a stronger oxidizing agent. Stronger oxidizing agent than your zinc ions. Okay, so we know that copper ions is stronger oxidizing agents than your zinc ions. So your copper will be reduced. Right, stronger oxidizing agent, so then it will be reduced to copper. Okay, then that's it. That's question 8 and 9. I think we're gonna do another past paper of both question 8 and 9, and then I think then we can also then start with maybe chemical industry. I think then we'll be able to maybe also go through your chemical industry. Yes. Okay, cool. So I'm just looking for another past paper. I'm just gonna quickly upload it. Okay. There you go. So this is the Gauteng Physical Science 2022 past paper. Okay. This is also downloadable, Gauteng Province 2022 September past paper. Okay. And we're going to be going to page 13 or maybe 14. Okay, there it is. Okay, cool. Just one moment. Okay, so it says that the galvanic cell represented in the diagram below consists of a Ba electrode dipped in Ba NO3 solution, okay, and a copper electrode dipped in a copper NO3 solution. If I'm not mistaken, NO3 is your okay. Okay, sorry. So it says a galvanic cell represented in the diagram below consists of these two electrodes, right? Your Ba electrode and your copper electrode, okay? And they dips in solutions. And then we need to assume that the cell operates under standard conditions. Again, standard conditions, 25 degrees Celsius is our temperature. And the second part is that, let me quickly check. Okay. So our standard conditions is that our temp and then our concentration is concentration of electrolytes, it's 1 mole per cubic decimeters. Okay, cool. So then they say state the two conditions under which the cell operates, just like I've just mentioned. Temp 25 degrees Celsius, concentration concentration of the electrolytes. Right, the concentration of electrolytes is then 1 mole per cubic decimeters. Okay, which half cell, A or B, is the cathode? Okay, so this is similar questions. If you understand what is a cathode, if you understand what is an anode, then you'll be able to answer these questions. Okay, which is a cathode, A or B? In this case, our answer is B. Okay, write down the half reaction that takes place, right? So we say anode, positively charged, by which the electrons leave an electric device, then your cathode, negatively charged, right? And then we know that um, anode, it's an electrode of a chemical cell at which oxidation occurs. Cathode, reduction occurs. Okay, we know that with the copper, as we said before, copper is, it has a very strong it's a strong oxidizing agent, which means that most likely reduction is going to happen. So that's why it is our cathode. It's negatively charged, reduction is going to happen, so it is B. Okay. 8.3, write down the half reactions that take place at cell A. Okay, I'm gonna write down the half reaction that occurs at cell A. Okay, we have this. This is our reaction BA. Looks like an H. There you go. Which is solid, transforms and becomes Ba2 plus, right? It's a reducing agent. It's gonna lose. Oxidation happens here, so it's gonna. Okay. Then this is our answer. 8.4, write down the cell notation of this cell. Okay, so they were looking for half reaction, now they're looking for the cell notation. Like I said, your shorthand description of, and in this case, it's your galvanic cell. Shorthand description of your galvanic cell. Okay, so then that is your BA, which is solid. Okay, and becomes Ba2 plus. Okay, 1 mole per cubic decimeter. This is a negative sign. Then you have your copper, 1 mole per cubic decimeters as well, which then becomes, right, your Cu. Okay. You could have also written it as Ba, Ba2 plus, Cu2 plus, Cu. Okay, cool. 8.5 says calculate the EMF of the cell. So we're going to calculate the EMF of the cell. So we know that the EMF of the cell is equals to that of the cathode minus that of the anode. Okay, please note that no abbreviation in the formula is allowed, to write all of these out. Okay, so we're looking for that. The EMF of the cell is what we're looking for. So the cathode is then 0.34 4 minus negative 2,90. Okay, and that is equals to 3,24 voltage. Okay, then you have 6.2. We're going to skip 6.8.6.1. I think there was a mistake in this question paper. So then we have how will each of the following changes influences? How will each of the following changes influences the value of the cell's EMF as calculated in question 8.5? Write down only increase, decrease, or remain the same. So how will the following changes influence the EMF? When the temperature of the solution is increased, what's going to happen with the total EMF? It's going to, in this case, decrease. Okay, so if my temperature increases, right, it says the temperature of the solution is increases. If my temperature increases, right, then my EMF of the cell decreases. Okay, we're gonna go to question 9. This is weird. Okay, let me check this way. My questions are not appearing. Usually it would allow me to just jump up to the content, but this is not allowing me to do that. Okay, cool. It's allowing me to do that now. Nope. Oh, yes. Okay, cool. Question 9. Okay, so it says that on a new page, question 9, the diagram below shows an electrolytic cell used for the refining of copper in industry. Okay, so chemical industry. So it says that the diagram below shows an electrolyte cell used for the refining of copper in industry. Okay, so let me just make it a bit smaller. Okay, so this is the diagram. 9.1 states, state the energy convention that takes place in this electrolytic cell. So you need to state the energy conventions. So state the energy conventions that take place. Okay, so you have your electric energy to chemical energy. Okay, so that's what's happening here. Okay, I think we can see it. Okay, right here we have all of this. We have a battery, so we're converting electric energy into our chemical energy. Okay, 9.2. What will be observed at the cathode? Okay, cathode negatively charged. This is where um, reduction takes place. So they say what will be observed at the cathode, and the answer for that question is that. Let me type it out. Says um, a layer of copper will be deposited on the electrode. Will be a mass increase. Okay. What will happen at the cathode? So a layer of copper will be deposited. So on this side, a layer of copper will be deposited on the electrode, and then there'll be a mass increase because it's gaining your copper metal on it. Okay. Write down the half reaction that takes place at the anode. Okay. So I'm gonna write it down here. Okay, 9.3. Write down the half reaction that takes place at the anode. Okay. In this case, it's not possible for this cell. Okay. And then you would have gotten your 2 marks. Okay. 9.4 states what will happen to the color of the blue copper sulfate solution as the reaction progresses. So what will happen with the color of the blue copper reaction, solution, blue copper sulfate solution as the reaction progresses, the blue color, so the blue color will go lighter. So the blue color will go lighter or it will go clear. Okay. Or okay, so the blue color will go lighter or go clear. Everyone's saying, "It's not my color. What are you? Oh, what are you?" Or the blue color will remain unchanged. Or the blue color will remain unchanged. Okay, so let me just drag it in. The blue color will go lighter or go clear, or the blue color will remain unchanged. Okay. I think that, especially for chemistry, we haven't necessarily done much. So I think we will. So it ends at question 9. Yes, ends at question 9. We've done electrochemical reactions as well as chemical chemical industry. I think especially with chemistry, I think we're gonna start at the beginning, with the time remaining to kind of do revision of term one's work. So I think at the end we'll go through how to kind of go about solving your multiple choices. Okay. But I think let's kind of start with chemistry. It's term one's work. We're doing organic, doing organic chemistry, working with your organic compounds. Okay, so we're going to start out here. This is just going to be like a quick revision of the work that was done in term one, moving through, and we're going to work through this past paper. We kind of have like close to like 20 minutes left, so I think we'll be able to do that. Okay. Okay, cool. So let me just quickly see which paper is this. Okay, so this is the Gauteng. Okay. And we're on page 7. Okay, cool. So it says the following type of formula represents organic compounds. Study the table below and answer the questions that follow. Okay. I hope I'm not confusing. We've done electrochemical reactions, we've done chemical industry, we've covered 2 past papers of it. It's important to kind of brush up on how to, write your half reactions? Do you understand what cell notation is? Do you understand what a cathode is? What an anode is? Do you understand what oxidation means and what an oxidizing agent is? Do you know what reduction is and what is a reducing agent is? I think it's quite hard with these type of lessons where I'm just gonna try to go through past papers because I don't really know what exactly you're struggling with, but you can always kind of let me know. But then right now we're just gonna go through the past papers, answer the questions, see how they are, how the questions are asked. How do you answer those? So we're done with our electrochemical reactions. Now we're gonna move on to the beginning of term one's work, I think, or term two as well. So we're going to do question two where we're speaking about the organic compounds. Okay, so with A, with B, we have C, D, E, all the way up to G. So it says from the table above, consider compound B. So I think we'll be able to just do question one, question two only, but that'll be fine. Okay, two, three, four, five, six, seven. Okay, maybe two and three. Okay, so it says the phone. Where are we? 2.1. For the table above, consider the compound B. So we're looking at this compound over here. It says 2.1.1. Homologous series. Homologous series. So write down the homologous series to which compound B belongs. Okay. So you have a couple of homologous series. Okay. And then you need to now choose which one does compound B belong to. Okay. Homologous series is a series of compounds with similar chemical properties and functional groups differing from succession's members. Ah, okay. So you have your alkaline, you have your alkaline, alkaline, you have your hello alkaline, you have your alcohol, you have your ester, you have all of these, right? Nitroalkaline, um, oxalic acid. So you have all of these different series. They have general formulas and they have a specific way in which they look like. Okay. So now they're asking you which homologous series does compound B belong to, and compound B belongs to your ester. Okay. And then how does the ester? So you have ester. This is the general formula, right? So this is how their general formula looks like. Let me quickly write general. Am I writing? There you go. General formula. This is specifically for an ester. Okay. So their general formula kind of has CnH2n plus 2 oxygen. Okay. The IUP, the IUPAC, okay? Write down the IUPAC name of compound B. So what is that? So now you have to then be able to kind of write down the name of the compound. Okay, I know that it forms under my ester group, my homologous series, and now we're looking for its compound name, and that is, there it is, methyl propionate. Okay. 2.2. An alcohol and an acids are heated in the presence of concentrated sulfuric acid to form compound B. Okay, so an alcohol and an acid are heated to produce the concentrated sulfuric acid to form compound B. Write down the role of the concentrated sulfuric acid in this reaction. So we're looking for the role. So what is the role of a concentrated sulfuric acid? Its role is catalyst, or it's to speed up. So it's either a catalyst, or it speeds up the reaction. Okay, it's either catalyst, or it speeds up the reaction. Okay, 2.2.2, name the alcohol and the organic acid used to prepare compound B. Name the alcohol and organic acid used to kind of prepare compound B. We have your propane, propanoic acid and your methanol. Okay. 2.2.3, name the type of reactions that is taking place. And in this instance, we have know that it's our esterification. That's the reaction that's taking place. Okay, esterification. Okay, cool. So then we have 2.3. So 2.3.1 says, from the table above, consider compound C. So now we're kind of dealing with compound C over here. It says that write down the name of the functional group of compound C. So now you have a look at it over here. We're looking for the functional group. Okay, write down the functional group of compound C. And that is your carbolic, carbolix, carboy group. Okay, my pronunciation is probably going to be horrible when it comes to the chemistry and the name of these groups and, stuff and these homologous series. They say to which homologous series does group C belong to? And that is carbolic, carbolics, carbolic acid. Carbolic acid. So it forms under the carbolax group, so it's carbolic acid. I'm butchering these names. It says differentiates between the term functional group and homologous series. So what is the difference between the two? Please tell me. Okay, cool. Let me do this. Okay. Here is the difference between the two. Oh, I can put it at the bottom. I'm going to put it down here. As a homologous series, a series of organic compounds that can be described by the same general formula. Just that's why I wrote the general formula of the other one in the beginning of the questions, or in which one member differs from the next with the CH2 group, right? And a functional group is a bond or an atom or group. It's a bond or an atom or a group of atoms that determines the physical and chemical properties of a group or organic compound, as long as letters indicate differences between the two. So you could have just kind of said one has general formula, or one in which one member differs from the next one, and then you could have you didn't have to you could have chosen one. So you could have said homogeneous series of organic compounds that can be described with the same general formulas, while a functional group is a bond or an atom or group of atoms that differ, that determines the physical and chemical properties of a group or organic compound. Okay, and the question says 2.4 from the table above, consider compound A, D, and F. Write down the homologous series in which they belong. So now we're looking at A, and we're looking at D, and we're looking at F. So A, D, and F. So A, you have D, and you have F. Looking at all of these, which homologous series do they belong to? Take the time to kind of consider all of them. And then these are all alcohols. Okay. Compound A and D are isomers. Okay. As what type of isomers will they be classified? Okay. And they will be classified as positional. Yes. Yes. Okay, this is what they as positional. Okay. Then it says draw the structural formula for compound F. Okay, so we need to draw the structural compound, which will look something like this. Okay, I'm gonna quickly draw it out down here. Okay, so we're gonna have C, just gonna have one, it's an H, two, three, bonded here, one, two, three, another C with one, two, three, and the O and the H. Okay, give yourself enough space. You don't want your H's to clutter. Okay, we need to be able to see them. Okay, so you have methyl and alcohol on both on the second C. So you have methyl on the second C. Okay. So then you have 2.5 says write down the IUPAC name for compound G. I'm just gonna quickly go back to it so you guys can see it. So now we're looking up here at compound G and we're looking for the IUPAC name. So you have, let me write it here, 5 bromo 2 dimethyl hexane. Okay, that is its name. Then you have structural formula for compound E. So the structural formula for compound E, which is this one over here, I'm going to draw it here. Okay, so you have C, because you have 2, 4, dimethyl, pentyl, 1 A. So this is how it would look like. Okay. O, it looks like an O, and it's meant to be a C. Okay. I didn't give myself enough space. And now, okay. I think hopefully in the next chemistry lecture, we'll kind of go through a lot of revisions starting from starting from term one to term two, and then kind of do more past papers of then your term three work, which is your electrochemical reactions and your chemistry industry. Okay. Yeah, that is it. Thank you.